acceleration due to gravity of a falling object is negative 32. That's the magnitude. So here's an object, and it's falling down, and there's ground level, and this gravity is pulling down. It's getting faster and faster. Suppose its air resistance is none, so it is given by simple formula. So the fact is that the gravity is hard enough to pulling down like this. So acceleration at, and there's a velocity they're asking, and here at the time t equals 3, falling object had a velocity of negative 10 feet per second, means going down, and this is where y equals 0 maybe. That's the positive direction. So if it is falling down in here, velocity is negative, acceleration toward downwards negative. So how is these two things are related? Anybody remember? Right. What is the derivative of what? Derivative of velocity. How fast the velocity is changing is the acceleration, right? Acceleration. That's velocity. So we know acceleration. What kind of acceleration is it? It's not at one moment negative 32. It's a constant acceleration, right? So it's a constant function, negative 32. Constant function. Look at it. At the time t equals 3, velocity is negative 10. It doesn't mean it's negative 10 all the time. At that moment it's negative 10 because the gravity is pulling down, it's getting faster and faster. But acceleration is a constant, right? So what is a good word of Vt in mathematical term of Vt in relation of At is antiderivative, right? So we're going to compute that antiderivative, At dt. And this is not going to be an antiderivative what we're looking for, right? It's going to be the collection of all antiderivatives. So what is the antiderivative of this one? Is negative 32. You pull out negative 32, you enter this basic function, and what is the solution in here? Negative 32 times t, right? Plus c1, and that's negative 32 times t plus negative 32 c1, right? But we're going to just simply write this one as c. So that's negative 32 c in there, right? This represents all the antiderivatives, correct? So from there we can conclude the following. The velocity that we're looking for, right, must be one of these. Must be one of these. That's a theorem. Every time it's an antiderivative, it must be in that form. So it's important to conclude here. So negative 32 times t plus some constant in there, right? So I'm going to use the c0, if that's all right. That's special constant for that object falling down. This one is just a mathematical calculation. It's representing everything. So we got this nice part, and what is c0? And they gave you that information. When t equals 3, velocity was negative 10 feet per second. That information will allow you to determine that c0. Does that make sense? So let's write that down. When t equals 0, what was the velocity? Negative 10, right? So you put that into this equation in here. So negative 10 is v3. Then we have this formula, negative 32 times 3 plus c0. That allows us to determine that c0 constant. And what is it? c0 is a plus positive 32 times 3 minus 10. That's 96. So it's 86. Yeah. So because of that, we conclude the velocity at time t in general is negative 32t plus 86 feet per second. So if you want to know how fast it's going at t equals 5, now you plug in 5, and that'll tell you how fast it's moving, falling down, right? So this is called initial value problem. So initial value problem is basically determining one more constant in there, which is given by initial value. Therefore, I hope you believe that if it has a solution, it has only one solution, because it completely determined that constant variable c. Make sense? Right? Usually you have infinitely many antiderivative, but answer to initial value, there is only one answer. Right? And this is all came from that mean value theorem idea. Alright? Have a great weekend.